the past 2 days we've been solving systems, but they have been with 2 variables. Today we're actually going to be looking at what happens when there are 3 variables in a system. Okay, so what does that mean? A linear equation with 3 variables means that we have an x, a y, and a z. Okay, A, B, C, and D are all numbers. X, Y, and Z, those are going to be your variables, so there's 3. Not all of them can be 0, so that's just our math information that we have to put in there. Okay, what does the solution look like? The solution is the values of the 3 variables that make each equation true. So we have to have an x, a y, and a z that make all 3 equations true. Okay, and it's going to have your 3 variables. Okay, so that you're going to get an answer for x, you're going to get an answer for y, and you're going to get an answer for z. When we plug those in, all 3 equations have to be true. Okay, so what's our answer going to look like? You guys know how we've had ordered pairs, x comma y? Now we're going to have what's called an ordered triple, and an ordered triple is x comma y comma z comma. So there's actually 3 variables in that triple. Okay, it's a coordinate still though, so you have to put it in parentheses. Okay, so must put in parentheses. Let's write that note. Okay, if it's not in parentheses, it's just a list of 3 numbers, and it doesn't mean anything. Okay, it needs to be in parentheses. X always comes first, y always comes second, z always comes third. So if we have 3 coordinates, do you guys know what dimension we're working in? The 3rd dimension, 3D. So we have 3 coordinates. All of our graphs have been 2-dimensional. There's just an x and a y. Now we're going to have 3-dimensional answers, but we're not going to graph it. Okay, so example 1. All I want to do is determine if -3, 4, 1 is a solution to the system. So what do you guys think I'm going to do? We're just going to plug it all in. So I'm using different colors for each one, but I'm also going to number them. So let's check equation 1 first. So right now we're just checking equation 1. So just put a little 1 next to it, and we're going to check this one. So we have 4 times -3 minus 3 times 4 plus 5 times 1 equals -19. So that's going to be -12. -3 times 4 is -12. Plus 5 equals -19. -12 minus 12 gives me -24. Plus 5 equals -19. Is that a true statement? What's -24 plus 5? -19. So that one's true, right? So it works for this one. So I'm going to put a check mark next to it. Let's see. I'll do equation number 2 in orange. So let's do number 2 right next to it. That's 3 times -3 plus -y. So plus -4 minus 8 times 1 equals -21. That's what we want. Okay, 3 times -3 gives me -9. -4 plus -4 gives me -4. And -8 times 1 is going to be -8. And we want that to equal -21. Okay, -9 minus 4, that gives me -13 minus 8 equals -21. -13 minus 8, what does that give me? -21. So that one works. So far we're looking good. Okay. Now, our answer is only a solution if it also works for the 3rd equation. So will you guys right now by yourselves check the 3rd equation? So label it number 3 and then plug everything in for me. So for the 3rd equation, I plugged in -3 for x, +4 for y, and 1 for z. Negative 2 times negative 3 gave me positive 6, plus 2 times 4 gave me 8, plus 3 times 1 gave me 3. I wanted that to equal 13. 6 plus 8 is 14, plus 3 actually gives me what? 17, which is not equal to 13. So it does not work for the third equation. So it works for equation 1, it worked for equation 2, but it did not work for equation 3. So is negative 3, 4, 1 a solution to the system? No, it is not. So let's write a big no, put a box around it. Alright, so then let's look at example 2. I didn't give you steps to solving yet, but we are going to use our logical reasoning here. So I want to solve the system x plus y equals negative 3z, or x plus y minus 3z equals 10, y plus z equals 12, and 2z equals negative 4. Okay, let's look at this. I have all three variables in the first equation. I only have 2 of them in the second, and I only have 1 in the third. So do you guys think I can do this without knowing the steps yet? Okay, can I solve for any of the variables right off the bat? Z, yeah, look at z. 2z equals negative 4. Can I solve that? Yeah, okay, so I'm going to, what I like to do in these problems is I'm going to label all of my, going to make the first one 1, so I'm just going to label it right now. We're going to make the second one 2, and we're going to make the third one 3. So if you don't have different colors, go ahead and just label them. But we can solve for z. So since we can solve for z, I'm going to just put a 3 next to it so I know which equation I'm working with. And we have 2z. Make sure that you make your z different looking than a 2, equals negative 4. How would I solve that? Divide by 2. So what does z equal? Negative 2. Okay, put a bubble or a circle around that. Remember, we have to write our answer as a triple, but we don't want to lose where z is, so I always just bubble it. Okay, so now that I know what z is, could I plug it into one of the other 2 equations to solve for a different variable? Sure, what about number 2? If I plug z in, I have y by itself, right? Okay, so let's look at number 2. So I'm going to put a 2 next to my work, just so I know what I'm working with. And I'm going to plug z into here. So this is y plus negative 2 equals 12. No, we can rewrite it as y minus 2, right? Equals 12. So then to solve for y, I just add 2 to both sides. So what does y equal? 14. Bubble that. Okay, now I know what z is. I know what y is. So I have all the information to plug it into equation 1, correct? Okay, so let's plug everything into 1. So that is x, we don't know it yet, plus y, which is 14, minus 3z, which is negative 2, equals 10. So x plus 14, negative 3 times negative 2 is plus 6, equals 10. That's x. 14 plus 6 is 20. So x plus 20 equals 10. Subtract 20 from both sides. So we get x equals negative 10. Okay, can I put my answer as all 3 of these separately? No, we need to write it as an ordered triple. So put your parentheses. And then it goes x, y, z. So negative 10, comma, y was 14, comma, and z was negative 2, and your parentheses. Put a box around it. Box my answer. So what if it doesn't all work out as nicely as it did in the previous example? We're going to have to use the elimination method. So just underline elimination so you know what method we're using. So we can use the elimination method because sometimes our equations, and if you guys look at like example 3, the variables don't always just stagger down. So what we're going to have to do when we want to use elimination method for 3 variables. First we're going to pair 2 of the equations. So you want to pair 2 of the equations and use elimination to cancel one of the variables. So we want to cancel one of the variables. Just one. Okay? Then what we're going to do after we've done that, we're going to pair another 2 equations, so 2 different equations, and use elimination to cancel out the same variable. Okay, so we want to cancel out the same variable. That's the most important thing about this. If you do not cancel out the same variable, it will not work. That's why I made it all caps, bold, and underlined it. Okay, it must be the same variable. Okay? So we're going to actually have 2 brand new equations. Okay, we're going to pair those equations. So pair the resulting equations from 1 and 2. Okay, so we're going to get 2 new equations from step 1 and step 2. You're going to pair those, and we're going to eliminate a new variable. Okay, so we're going to eliminate a new variable. That's going to give us an answer. So we're going to substitute that value into one of the original equations and solve for the remaining variables. Okay, on paper, in words, it sounds like a lot of work. In reality, it is a lot of work. So you need to make sure that you are organized and that you write your work neatly, because on a test, we do have questions like this on the test, and if your work is not neat and you get the wrong answer, it is very hard for me to give you partial credit. Okay, on previous tests, I have seen students where I can follow their work up to a certain point and then I can't follow what they're doing, and so I couldn't give them as much partial credit maybe as they deserved because I can't figure out what they did. So make sure, especially in these, that you are showing every single step and that you are working as neatly as possible, okay? Because even if you get the wrong answer, you can still get some points, okay? One reminder, and this will happen, and we came across this yesterday in our homework. A false equation in any of the steps means no solution. So if we ever get something that's false, like 0 equals 1, no solution. We can stop. Okay, so if all the variables cancel and we get a false equation, there's no solution. Any equation that is an identity or a true statement, such as 0 equals 0, 1 equals 1, that kind of thing, means we have infinitely many solutions. Okay, so if you ever, and this is for if variables cancel, so if all variables cancel, let's write that. If all variables cancel. So if we ever come across a point where all variables cancel, a false statement will give us no solution. A true statement will give us infinitely many solutions. Okay? Yeah, and we came across that yesterday in the homework, right? All right, so example number 3. My first equation is x plus 2y plus 3z equals -1. Second equation, 3y plus 2z equals -1. And x plus 5z equals -7. Now this one, we do sometimes have the equations, they're missing a variable, but it doesn't work out like the other one where we have just a z in the last one, right? So what we're going to do is let's label each of the equations 1, 2, and 3. 2 and 3. Okay. And let's start working. So step 1 says we want to pair two of the equations together to cancel out one of the variables. So that means we can pair 1 and 2, 2 and 3, or 1 and 3. What do you guys want to do? 1 and 2? I usually go 1 and 2. So what I'm going to do is I'm pairing 1 and 2. So let's just put 1, 2 next to each other. So that's telling me which two I'm pairing together. And then let's write it out. So we have x plus 2y plus 3z equals -1. And then I like to line up the variables, okay? So let's line up 3y plus 2z equals -1. Okay, so what we want to do is we want to eliminate one of the variables. So we can't eliminate x, obviously, right? Because we don't have any x's here. So what do you guys want to eliminate, y's or z's? Well, we have to eliminate z's, because let's look at it. I only have x and z's in the third equation, and in the second equation I only have y's and z's. So the only one that all three of them have in common is the z's. Do you guys see that? So that's going to be the one we have to eliminate. They all have to have at least one variable in common in order to eliminate. So we have to eliminate the z's here. So what do I need to multiply by to get the z's to eliminate? We have to multiply the top by 2. And what you need, so that means we need to multiply the bottom by, well, we want one to be negative, so -3. Okay, so I'm just going to rewrite the equations off to the side here. That's going to give me 2x plus 4y plus 6z equals -2. This is going to give me -9y minus 6z equals +3. So let's add the two equations together. 2x plus no x is going to give me 2x. What about 4y minus 9y? -5y. And then 6z minus 6z, those cancel. Equals 1. Okay, this is one new equation, and this looks like something we can work with, right? I want you to circle it. That way we know where it is, because we're going to come back to it. Okay? Alright, that was step 1. We combined 2 to eliminate one variable. So since we eliminated the z's in this step, we have to eliminate z again. So looking at our three equations, we have to pair two of them so we can eliminate z. We can pair 1 and 3 or 2 and 3. I like 2 and 3. It really doesn't matter. We're going to get the same thing anyway. So you guys want to do 2 and 3? Okay, let's do 2 and 3. So 2 is green. So then right up here I'm going to pair 2 and in blue 3. So I'm just labeling my work here. So we have equation 2, which is 3y plus 2z equals -1. And equation 3. I'm going to write 1x out here. I'm going to leave a blank space for that 3y so that our variables line up. Plus 5z equals -7. So I just left a blank space there because I don't want to line up variables that aren't the same. Okay? Okay, so I want to eliminate z again because I eliminated z in step 1. So that means I need to multiply the top by
-5.
You want to do -5? Okay, so we'll multiply the top by -5, which will give me negative 15y minus 10z equals positive 5. And then, so what do I need to multiply the bottom by?
2.
Positive 2, good. So that is going to be 2z, or I'm sorry, 2x. No y's, so I'm just leaving a blank space, plus 10z equals negative 14. You guys okay so far? We're going slow. Okay, let's add the equations together. 0x plus 2x is going to leave me with 2x. Negative 15y plus 0y's is just going to be minus 15y. Negative 10z plus 10z cancels equals negative 9. Circle that one. Okay. That was step 2. Step 3 is we take this equation and pair them together because look, we have x and y. We can do that, right? So let's take those two purple ones and pair them together to do some more elimination. So I'm going to do it off in the margin because I ran out of room. So I have 2x minus 5y equals 1 and 2x minus 15y equals negative 9. So that's why I wanted you guys to circle these because those are the two we're going to pair together. And now this looks like something we can do. Is anything jumping out at you right off the bat to eliminate? The 2x's, right? The only problem is that one of them has to be negative. So we can multiply, you want to do guys the bottom by a negative? So if I multiply the bottom by a negative, 2x becomes negative, right? Negative 15y becomes positive, and negative 9 becomes positive. Is everybody okay with that? I just changed the signs. So I multiplied the bottom by negative 1, and that changed all the signs. Okay? Let's add those two together. X's cancel. Awesome. Negative 5y plus 15y is going to give me positive 10y equals 10. Easy, right? Divide by 10, y equals 1. Put a bubble around it. We do not want to lose that. Okay. Y equals 1. Can I plug that into either of these two equations to solve for x? Now we're just doing straight elimination like we've done before. So I have a y. I need to figure out what x is. Which one do you guys want to plug it into? The first one? Okay, so let's do 2x minus 5y equals 1. So that is 2x minus 5 equals 1. Add 5. 2x equals 6. Divide by 2. X equals 3. All right, bubble it. Okay. We have x, we have y, we still need z. Where can we plug in x and y to solve for z?
The very first
Equation number 1. So let's plug it in. X is 3 plus 2 times 1 plus 3z equals negative 1. So I'm moving my work from up here to right here. Okay, this should be easy, right? 3 plus 2 plus 3z equals negative 1. So that's 5 plus 3z equals negative 1. Subtract 5. Darn it, I ran out of room again. So that gives me 3z equals negative 6. Divide both sides by 3. Z equals negative 2. Okay. One last thing. We have to write our answer as a coordinate. So x, comma, y, comma, z. So that is going to be 3, 1, negative 2. Box it. Alright, example 4. This is going to be mostly what you see. Okay, so example 4 is mostly what you will see. Notice how equation 1, I'm going to label it right now, has x, y, and z, right? Equation 2 has x, y, and z. And equation 3 has x, y, and z. This is more typical of what we're going to see, okay? So, let's pick two equations and pair them right off the bat. That's step 1. Which one do you guys want to pair? 2 and 3? Why did you pick 2 and 3? Yeah, look at what I like to do to look at what we can pair is, let's look at 1 and 2 together. We have 2 and 4x, negative 2 and positive 2y. That looks promising. And 4z and 8z. So you guys want to do 1 and 2 first? Okay, so let's pair 1 and 2 first. And so it should be obvious to us. I'm going to do it off in the margin. So let's do 1 and 2. Nope, 2 is green. Okay, so if I have our equation 1, that's 2x minus 2y plus 4z equals 6. And 4x plus 2y plus 8z equals 12. Okay, what variable am I going to eliminate here? The y's. It's already set up for us, right? So let's eliminate the y's. What is 2x plus 4x? 6x. Negative 2y plus 2y. They eliminate. 4z plus 8z plus 12z equals 18. Circle it. Okay. That was our first one. Okay, so in our first step, we eliminated the y's, which means we have to eliminate y's again. So look at our remaining equations. If we have to eliminate y's, which one do you guys want to pair? 2 and 3, right? Because one is already positive and one is already negative. So let's pair up 2 and 3. I think I might be able to fit it in the margin again. 2 and 3. Okay, so 2 is going to give me 4x plus 2y plus 8z equals 12. And 4x minus 2y plus 8z equals 12. Okay, let's add those two together. 4x plus 4x is going to give me 8x. Positive 2y minus 2y cancels, which is what we wanted to happen. And 8z plus 8z is plus 16z equals 24. Circle that one. Okay, so now I have X's and Z's only in the purple. So let's pair those together. So step 3, we're going to pair these two guys together. So I'm going to do it up here. 6X plus 12Z equals 18. 8X plus 16Z equals 24. Okay. Does one... Okay, so let's look at 12. The Z's are a little bit big, and it might be a little bit harder to find something for them to be the same. So I want to look at the X's here. What's the least common multiple of those two numbers? 24. And 1 has to be negative. So what do you want to multiply the first one by? Negative. Well, we could, but that would give us 48. Let's do 4. How about negative 4? Which would mean this one has to be positive 3. Okay. I'm just going to write it right below. So when I distribute, that's going to give me negative 24x minus 48z equals negative 4 times 8 gives me 32, 72. Okay, distribute the 3. So that's positive 24x. 3 times 6 gives me 18, positive 48z, right? Equals
72.
positive 72. Uh-oh. Anybody see what's going to happen here? When we add the two equations together, negative 24 plus 24 cancels. Negative 48 plus 48 cancels. So I'm left with what on the left? 0 equals negative 72 plus 72? 0. Is this a true statement or a false statement?
True.
True. So our answer is infinitely many solutions. We got a true statement, and all of our variables canceled each other out. So we have infinitely many solutions. All right, example 5. We're going to have to underline some stuff, okay? And I'm actually going to do my work for 5 on the back. Okay, one shopper bought 2 packs of gum, 3 candy bars, and 1 bag of chips for $3.07. So I'm going to underline that in orange. That's going to be my equation 1. Equation 2, a second shopper purchasing the same brand paid $3.79 for 3 packs of gum, 2 candy bars, and 2 bags of chips.
That's 33 packs.
3 packs of gum. A third person bought 4 packs of gum, 4 candy bars, and 3 bags of chips for $6.01. Find the cost of each item. So, what we're going to do is first we need to identify our variables. So, is everybody okay with using G for gum, B for candy bars, and C for chips? Okay, so we have to actually write that down. So for number 5, I'm going to use it on the back. So for example 5, G is going to equal the cost of gum. We're going to have B equal cost of candy bars. And C is going to be the cost of chips. Okay, we should be able to make 3 equations. So what I want you guys to do right now by yourselves, try and write your 3 equations for me. Okay, so go back and look at the problem, and you should be able to write 3 equations. So 2 gum, 3 candy, 1 chip. So we have 2 gum, 3 candy, 1 chip. 307. gum, 2 candy, 2 chips. 3 gum, 2 candy, 2 chips equals 3.79. 4 gum, 4 gum, 4 candy, 3 chips equals 601. You guys ready?
Nope.
What do you think? Here's what I got. Okay, here's what I got. 2 packs of gum plus 3 candy bars plus 1 chip is 307. Second equation, 3 gum plus 2 candy bars plus 2 chips is 379. 4 gum plus 4 candy bars plus 3 chips is 601. Everybody okay?
Yeah.
Okay, even though we have decimals right here, I'm going to leave them. Are any of you totally against that? The only reason I don't want to take away the decimals is because if I move the decimals over 2 spaces, that's going to give me 300 plus 200 plus 200, right? It's going to give me really big numbers. I'm more comfortable with just working with these decimals. Is everybody okay with that? Okay. So we'll probably need a calculator, so if somebody has a calculator handy. Alright, let's look at all of our variables. They all look pretty different, so basically what we're going to do is just pick 2 equations and start eliminating something. So which 2 do you guys want to pair together? 1 and 2? Okay, let's go. So 1 and 2. Those are the ones I'm pairing together. So we have 2g, and I would leave a little bit of space because we're going to have to multiply, plus 3b plus c equals 3.07, and 3g plus 2b plus 2c equals 379. Okay, so this is the moment of truth. Right now we are going to pick which variable we want to eliminate. And we're going to have to stick with that variable for the next step. So let's look. I have 2g and 3g, 3b and 2b, and 1c and 2c. Anything look easy?
Yeah.
C. If we multiply the first equation by -2, we don't have to do anything to the second, right? Okay, so that's going to give me -4g minus 6b minus 2c equals -6.14. I'm going to rewrite this guy right underneath it. So 3g plus 2b plus 2c equals 3.79. Okay, let's add those 2 equations together. -4g plus 3g, -1g, -6b plus 2b is -4b, -2c plus 2c cancels, equals, okay, -6.14 plus 3.79, -2.35, circle it. Okay, so we eliminated C's. So let's look at what we have left. If we want to eliminate C's, what 2 do you guys want to pair? 1 and 3? Only reason why I would say 1 and 3 is because we have that C by itself, right? So let's do 1 and 3. 3 is Okay, so 1 is 2G plus 3B plus 1C equals 307. Equation 3 is 4G plus 4B plus 3C equals 6.01. Okay, because we eliminated C's in step 1, we have to eliminate C in step 2. So we need to multiply the top by what? Negative 3 this time. Good. So that's going to give me negative 6G minus 9B minus 3C equals negative 1, 2, 9.21. Okay, and then the third equation gets to stay the same. So I'm just going to rewrite it underneath. 4G plus 4B plus 3C equals 601. Okay, add those two together. Alrighty, I'm going to scooch this up a little. Okay, negative 6G plus 4G is negative 2G minus 5B, those eliminate, equals negative 3.20. Circle that. Alright, so we have, I'm going to pair these two now, negative G minus 4B equals negative 2.35, and negative 2G minus 5B equals negative 3.20. Okay, looking at these two equations, our two new ones, what variable you guys want to eliminate? G's. G's are easier. So what do we need to multiply that top equation by? Negative 2, because we want it to actually become a positive 2. So that's going to give me positive 2G. Negative 2 times negative 4 is plus 8B equals positive 470. And then I'm just going to rewrite this one. So negative 2G minus 5B equals negative 3.20. Okay. Negative 2G minus 2G cancels. I get 3B equals 1.50. Oh, good. This is going to come out nicely. Divide both sides by 3. So B is equal to, this is money, so remember dollars, 0.50. 50 cents. So those are, candy bars are 50 cents each. Okay. Now I have B. I can solve for G by plugging it back into this guy, right? Yes? So if we plug B back into here, we can solve for G. So let's plug it in. We have negative G.
You never plug it into the one.
So we have negative G minus 4 times 0.5 equals negative 2.35. So negative G minus 4 times 1/2 is 2 equals negative 2.35. Add 2 to both sides. So negative G equals negative 0.35. But we can't have negative money or negative gum. So let's divide both sides by negative 1. So G equals positive 35 cents. Okay. Almost done. This is the easy part. Alright, so I know B, I know G, so now I can plug it back into one of my originals to solve for C. Which one you guys want to plug it into? Let's look at number 1. So I'm going to plug those two back in. So this is going to give me 2 times 0.35 plus 3 times 0.5 plus C equals 307. Okay, 2 times 0.35, that's going to give me 0.70, right? Plus 3 times 0.5, that's 1.5. 0. Plus C equals 3.07. 70 cents plus $1.50 is going to give me 2. What do you guys get? 20? Yeah. Plus C equals 307. Subtract $2.20. So C is going to equal that's a 87 cents. Yeah. So chips cost 87 cents. Candy bars cost 50 cents, and gum costs 35 cents.